welcome. Thank you for coming out on this Arctic below zero wind chill day. All those Bostonians call us winter wimps, but not this group. Maybe we're snow wimps, but we can deal with the cold. So I'm John Mahar, Executive Director of Reset, and we're glad to have you here today for our volunteer seminar. And our topic today for the panel is going to be what makes a reset session exciting to the students. So we have asked you to get students to fill out an evaluation form at the completion of the program. And one of the questions we asked, what was your favorite experiment? And it's interesting that it does seem to be an amazing amount of convergence in the way that students respond to that in any given program. So some of these sessions really resonate with them. And since our objective is to let the students know that, or get them to learn that science learning is exciting, we are very interested in what kind of things resonate with the students. So before I introduce the panelists, let me introduce Roberta Gore towards the back. Most of you have crossed paths with Roberta at one point or another. She's our volunteer coordinator for Reset. So she'll I usually meet with the volunteers first and meet with new schools first to get things set up, and then Roberta takes over and schedules all your sessions after that. So we're very grateful for the work that Roberta does for us. So let me introduce the panel. I'll start at the far end. There is George Peck. And George has a doctorate in mechanical engineering, worked in the field of aerospace, and he's been a Reset volunteer since 2010, and has worked at Key Elementary, Graham Road Elementary, and is now at Barrett Elementary, all in the Arlington/Falls Church neighborhood. So welcome to George. Thank you for joining us today. And sitting next to George is Susan Garman. Susan has a master's degree in early childhood education from Trinity University in DC. She presently teaches science enrichment, grades K through 5 at Barrett Elementary in Arlington, Virginia. Barrett is one of our handful of Reset Core schools. And since science enrichment is what Reset is all about, we're very glad to have Susan join us today as well. James Elstrom, I'm sorry, let me go come back to you in a second. I got to Brittany. Brittany Nunes is 22 years old and recently graduated from the University of Delaware with a degree in health and physical education. Brittany is a first-time fourth grade teacher at Cora Kelly Elementary in Alexandria, and has just completed her first experience with the Reset team, and that team is from the Society of Hispanic Professional Engineers at the U.S. Patent and Trade Office, which does bring me then to James Elstrom Acevedo. Those V's always confuse me in Hispanic names. He's a supervisory patent examiner at the U.S. Patent and Trade Office, where he's worked for almost 10 years. James earned his PhD in inorganic chemistry from the University of North Carolina at Chapel Hill, and his Juris Doctor degree at George Washington University. He's an active member of the U.S. Patent and Trade Office chapter of the Society of Hispanic Professional Engineers, which has volunteered at Cora Kelly for several years. And I think I will invite and introduce Sherry now, even though she's going to be our presenter after the panel. So Sherry Core is an adjunct professor at George Mason University, teaching undergraduate education students in a program called Teaching and Learning in the Sciences. With a strong background in hands-on STEM education, Sherry serves as Reset's volunteer classroom skills developer. She will travel to your school and observe one of your classroom sessions. I know some of you have already taken advantage of that opportunity. And we encourage all our volunteers to do that. And then Sherry will make suggestions based on her observation, and will engage in a follow-up dialogue with volunteers as well. So every moment of time you give to your students is valuable. So with Sherry's help and assistance, we want your classroom impact to be as positive as possible. I also wanted to introduce one other person to you, and that's David Adler, who's on the Reset Board of Directors. And David's been in that position for about a year. So I think today we will start with the volunteers who will demonstrate or describe an experiment that they do, the kids get a charge out of. And then we're going to ask our educator volunteers to talk about their kind of broader perspective on what gets the kids excited about science in the classroom, and if they want to make any specific comments about these experiments, that'd be great. I know that James has brought his tsunami experiment, but
it's kind of frozen.
It's frozen. Oh, thank you. So, with that, why don't we start with George?
Thank you very much. An encouraging note is that all what I am going to say, and if you are not understanding me, that's okay, because everything is written down in your packet, which was provided to you. It's below the So I would like to speak just a few minutes, or a few seconds actually, about the teacher and volunteer interaction. When I became a volunteer 4 years ago, this was a question in my mind. What are the important interplays between a teacher and a volunteer? And this is what I found, my opinion only. The most important thing there is a mutual respect between teacher and volunteer. And I have had experience in both ways. That is, mutual respect yes, or mutual respect no. So that's a very important point. Another point is that the teacher and the volunteer should agree way before the experiments, way before the class session, on what they are going to do and how they are going to coordinate and who is going to bring what to the school and to the class. Now, the contribution the teacher makes in this partnership is an effective teaching, the art of effective teaching, and knowing the children, each individually, as well as how they interact with each other. That's very important. They know their individual capacities, curiosities, and of course the final judgment in all experiments falls to the teacher. But usually there is always a good discussion and we agree eventually. Now, the contribution the volunteer makes is critical in the following areas. Obviously the volunteer has to be an expert in one branch of science or another. And I am an expert more or less of physics and engineering. And then able to design experiments which are appropriate to the level of classes which are going to be taught and worked together. Of course, the experiments design and how you conduct it is the teacher's final judgment is for the teacher, apparently. The interaction is very, very important. And what we do, for example, just to give you a concrete example with Ms. Jarman and myself, is I usually give quote-unquote a lecture which lasts roughly 10 minutes, 10, 12 minutes, and I use the so-called Socratic method, which is to ask the children questions. and engage them from the beginning and stimulate their interest and their curiosity. And that seems to work. After which we take the class of 20-25 students and divide them into 4 or 5 groups of 4 or 5 students. And then I work with 2 groups usually, and Ms. Jarman works with another 2 groups. But she is keeping an eye on me, and if there is a problem with the group, she always gets and comes to the rescue. We use the scientific method, which is, I am going to show you what it is or how Barrett is using it. And it's simple, the children understand it. I assume that this scientific method is already being taught all the way in the beginning, within 3rd and 4th grade, right, in 3rd and 4th grade. And within this little group of 4 or 5, I try to engage each of them separately with some procedure or some thing, so they would not be on the top of each other. And that's very easy because we use a procedure, and the procedure has different tasks, and these different tasks could be performed by an individual. So for example, in this experiment, there is going to be a kid, in this case myself. Okay, but there are some other questions which many teachers do or do not ask. For example, I mentioned that the mass does not really make any difference in here. You can demonstrate that. In Barrett this year, and I think it was an excellent idea, they essentially introduced the concept of dependent and independent variable, because that's very, very important for later on in mathematics, for example. So what is the dependent variable? The dependent variable is the one which the experimenter is going to do. For example, the length of this thing. The independent one, of course, is the time of the cycle. But there are other questions which people don't even think about. For example, is the velocity of this pendulum, is this velocity going to change as it goes through? Does it or doesn't it? Well, it's hard to see. There are some ways to measure it. But if it's long enough, I think the children can see it. And we can then talk about energy and talk about the 2 kinds of energy. The potential energy, which is essentially the length is, the swing length, and the kinetic energy, which is associated with the motion of this thing. Now the question is, for example, if you have swing length from here to there, will the cycle per second change or not? Or if I do it from here, will the cycle per second change or not? The answer is, of course, no. But what will change is the kinetic energy, the speed. And the speed is 0 here, and it reaches maximum down here. Okay. Now, I don't want to bore you with the mathematics, but with this you can essentially measure the force of gravity of the Earth. And it's a very simple, not even, well, an equation which has everything in here which we did already, which is the length and the time. And that's all you need, and you have a constant which is 39.4 essentially, and you can find out what G, the force of gravity, is. Another thing which kids don't know is that you can measure the rotation of the Earth with the pendulum. If you remember the old Smithsonian Institution, they had a big pendulum from the top, and it moved very slowly across. It's called the Foucault's pendulum. And the Foucault's pendulum essentially shows that as the pendulum swings, the Earth rotates. And they had these little things there, and every hour, on the hour, the pendulum sort of hit one of the hour measures. So all these things, and these are only a few. Now what we do using the scientific method is to observe it. We show the children that it does this, and then the questions, as I mentioned, are many, and you can choose one of many. If you are a second grader, for example, you can choose a very simple thing. What is your guess how many times is it going to swing before it stops? And there are many different guesses. So a hypothesis is the next thing which you do, and the hypothesis is the guesstimation of what will happen. And of course the materials list, as I mentioned, procedure, which is written, and as I mentioned, the two variables, and then the results, which usually say your hypothesis is right or your hypothesis is wrong. And if your hypothesis is wrong, why? And so this is, I have my 10 minutes up, I guess. This is what we do in Barrett.
Okay, if there's time afterwards, we can get into more discussion.
That's right.
Thank you, George. So James, you want to talk about your how you get kids excited about science?
Oh, well, maybe you can help me.
I'd be happy to.
All right, so we have the start of, this is an apparatus we use to simulate a tsunami. I don't know if the camera can catch it. You've got frozen sand, it's not frozen on the actual program. And the sand is kind of the shoreline, and it's slanted up, and we've got water in the rest of the tub. And we start off by explaining what tsunamis are to the students, explaining that engineers can't control or prevent a tsunami, but what they can do is use different materials to make different structures that might be able to resist the effects of a tsunami. So we usually start off, we'll make little paper houses out of paper, and we'll set them on the shore, on the shoreline, at different places, and we'll kind of ask the students, well, what do you think is going to happen when the tsunami comes by? Which houses do you think what will happen to the houses? We'll ask them. And then we'll also have some houses that have these toothpicks, which act as stilts. So you can't really see it, or maybe you can. There's a little metal plate here, which we move to get the water to simulate the tsunami. And the students get to see the water going up the shore, getting closer to the houses, and then seeing the effect of the water on the houses. And so in their mind, they've been thinking, well, what's going to happen when the wave hits the shore, when it hits the house? Are the houses made out of paper going to fall apart? Are they going to get swept away? What about the ones with stilts? So they're thinking about this, and then they watch the simulation and see what happens. And then we have a different part to the experiment where we say, well, engineers, they have other considerations besides just like what problem they're trying to solve. They often have a budget, right? So they don't have an infinite amount of resources available to address the problem. So we assign different teams, and different teams have different budgets, and the different materials have different values and costs. And we have a tsunami over there. And so the teams decide what structures they're going to build based on the budget they have, and try to figure out, well, which structures are going to be best. And then each team, after they've done making their structures, they put them on the shore, and then once again we simulate the tsunami. And they can have stilts, so toothpicks, they can have it made with paper, with aluminum foil, with some other things. And so the students get to watch what happens, and we have them come in different groups. And they get a kick out of this because they get to see what happens, and they get very excited when a house they saw, which they thought might get washed away, doesn't get washed away. And then they have to think, well, why might that be the case? Maybe it's the material it's made out of. Maybe it's a combination of the material with the presence of stilts. Maybe it's the stilts material plus the location on the shore. If it's right up next to the water, maybe it's not going to do as well as something that's right in the back. That won't get as direct a hit from the wave. So, I mean, if you you probably can't see this very well, but if you want to come up and look at this, you can, and I invite you to do that. And just kind of imagine the water moving up the shore and how that might affect. And the students get to see in real time what happens. So they get a big kick out of it. I think Ms. Nunes here could share, what are your observations of the students when they saw the tsunami?
Well, I have videos for anybody who wants to see. There's a lot of screaming and, my house is better than your house. And so they get really, really excited about this one for sure.
Yeah. So that's kind of the tsunami experiment in brief. If you guys have any questions or
So James, if that is, it's liquid, not solid today. So when you bring it in, it's
there's a slant with the sand to come down, and then we've got water, I guess about a third of this tub.
Okay.
And then moving the metal plate creates the waves, and it displaces the water onto the shore.
Okay, so the sand is fixed, or
Yeah, it's packed down.
okay,
So
so it stays in place.
for the most part, yeah.
So how do you move the plate? Do you do it physically with your hand?
Yeah, move the plate like this, and or it's taped down, but you can do it like that, and that displaces the water onto our simulated shore.
So like tsunamis start from, they're not regular waves, right?
Right. So the wave of the tsunami is not just at the surface; it's all the way down. So that's why this design is felt that way. So to get that concept across, that the wave is not just at the surface.
Anybody wants to see a video later can come to me.
Okay, thank you, James. Brittany, why don't you talk a bit about the experiment in the classroom,
Yeah.
why your kids get excited?
Well, this was the reset team I worked with. Before I talk about them, I just want to talk about my school a little bit of background. Our school is 89.5% come from poverty, and 95% of them are minority groups. For the past 3 years, we've met and exceeded all federal benchmarks, and for the past 4 years, we've been in the top performing schools in our district. So I think it says a little bit about our students and the type of school that we have. We're highly based on science and math, obviously, and what kind of team it takes to come in and work with our special students. The fourth grade, especially, they're, to say the least, a very tough group of kids. They're very outspoken and loud, and it takes a lot to engage every single one of them. And somehow our reset team engaged all of them, and I personally think it was amazing. We love our reset team. Every time they're in there, they get so excited. The kids start screaming, Mr. Juan, Mr. Juan, as soon as they come to the gym. So they love reset. Some of the projects we did that stood out, the first one that stands out to me is the earthquake project. And that's for special reasons. They had to build structures out of toothpicks and marshmallows and then put them on Jell-O and shake them and see if theirs lasted. And you would think if you gave a fourth grader marshmallows to build a structure, they wouldn't smash them all together and then smash them on your gym floor, but they do. And so the amazing reset team definitely stayed and helped clean up after, which was very nice of them. But they loved that one. It's hands-on learning, which is great. What other projects? The tsunami one, of course, and I have videos to show everybody, but they got so excited for this one. And when they said they were going to get a budget, and some teams are going to get $500, some are going to get $100, they're like, wait, real money? And I'm like, no, you're not getting $500. But they were very excited and using different materials to create different houses, and they challenged each other, they challenged themselves. Some of them get really discouraged when their house didn't last and they didn't understand why. That it's not just the materials, it's not just the location or the structure or natural disasters in general, it's everything combined. So it taught them a lot, and I think it worked well with what the students were learning in science at the time. They were learning about, I push into 3rd and 4th grade science when I'm not teaching health and phys ed, and they were learning about tectonic plate shifts, they were learning about the levels of the ocean, and so everything really coincided well. That was one of my personal favorites. The other one I would say was the lesson on biomimicry, which was very cool. One of my personal favorites for different reasons other than what the experiment actually was. The students get to create their own invention based off something in nature. And I loved it because the creativity and the imagination that was sparked inside the students from this lesson was incredible. And I think it's important with this special group of kids and how they act and where they come from, that they need to be able to imagine being able to create something great like that. They need to know that they can be inventors. And this lesson brought it to the table. It was incredible. Some of my students came up to me and they're like, "Miss Nunes, can I tell you my invention?" I'm like, "Yeah, sure, what is it?" And they were like, "Well, you know how caterpillars make cocoons to protect themselves before they become butterflies?" I'm like, "Yeah, I know what a cocoon is." And she told me, "Well, I'm going to make an indestructible house of leaves, like a cocoon, for all the cocoons until they become butterflies, and then they can all go away." And I was like, wow, an indestructible house of leaves. But just looking at that, it's like you had to use your imagination, your creativity. You get to share it with me. You get to share it with your classmates. You get to share it with people from the Reset team. And some of them came up with really cool inventions. But other than the inventing part and basing it off nature, the fact that they were allowed to use their imagination and creativity and share with their peers and with teachers and outsiders, it's huge for them. The cooperation and communication that Reset involves is also really big for that specific age group and those kids. A lot of our kids have emotional disorders and attitude problems, to say the least, and to be able to work cooperatively and communicate with others is huge for them. So they were able to work individually, they were able to work in groups, they were able to work with adults, and every single one of them were engaged. I can't think of one student that didn't love coming to Reset and love working hands-on with the projects that they brought to the table. One of the biggest things I think helps is that Reset touches so many different strategies of learning. You have a visual aspect where they show you experiments, they show you different inventions that have come from nature, they show you other experiments that they've worked with, and then they're speaking to you, and you're talking to them, and you're talking to your partners, so that's auditory learning, and then of course the hands-on learning, the kinesthetic learning. You're touching students on a visual level, an auditory level, a kinesthetic level, and any study will show you that the more strategies you can use with a student, it's going to progress their learning. And so when they go into science class and they're learning about the levels of the ocean and tectonic plate shifts, they're like, "Oh yeah, well we did that tsunami creation, I saw the waves coming from the ocean, I saw the levels of the ocean." So they have all those different strategies of learning, and it progresses their learning, it progresses their knowledge, and I think just overall gets the concept across much better than a lecture. I think that might be it. All the group work, the imagination that comes into play, it gets them excited about science. Hands-on work is always great for kids. And I think with this specific group, our Reset team was amazing. And I can't wait for them to come and work with third grade, and they're much easier, I promise. Fourth grade is pretty tough, but they're looking forward to it, and I loved working with them, and I hope there's more years to come. This is my first year teaching, so obviously my first time with the Reset team. I couldn't have asked for anything better, and I'm looking forward to more experiences. Thank you.
Thank you. Susan?
So I'm going to start with, as you know, it takes a whole village to raise a child, and you never know what it's going to be that inspires the children that you're working with. It may be something that you say or something you do, so it is really important, the things that you do with us. George and I have been working together for 2 years now, and some of the things that Brittany talked about, but I'd also like to point on, is that it's really important that you include in your lesson visuals, the vocabulary, possible worksheets, and so on, so that the kids are engaged at all times. Do keep in mind that depending on what area you're working, there are either Virginia State standards or the core standards, and so on. So you may not have to exactly follow those, but it's helpful if you have an idea of what's expected of the students So you know if you're not way above them or way below them, you're kind of in their zone of proximity. With that said, know that we as educators may not always agree that what the state or the federal government has chosen to be that standard necessarily fits with that grade or that age. It is a helpful, it's a way to go that gives you a basic idea of what's expected of those students at that age, so that you have an idea of what they're supposed to be able to do. You might also have an idea of where they've come from, things that they've already learned in the past, or may have a basic understanding that will help you in the future as well with the activities you're putting together. Also know that our schedules tend to be really tight. And so if we say, you know, our time is 9:45 to 10:15, at least this is how ours works, we really only have 9:45 to 10:15. And so we need to make sure that we stay within those schedule blocks. Be excited and show your enthusiasm. And like George said, we spend a lot of time emailing back and forth lesson plan ideas. A lot of people think teachers, oh, they get off at 3 o'clock, you know, they've got it made. Well, I've got a whole bunch of homework out in the car that I plan on doing this weekend. And when we were preparing for our lessons, I was sending a lot of emails on things that I had put together. Did I do this right? Are these correct? And there were things he was sending back saying, you might want to change it and say this instead. So, you know, once you get to know your people a little bit better and you get that relationship, it becomes easier to say, you really don't know what you're talking about. This is what it really is supposed to be. We have found that doing 2 days consecutive together, I don't know how you all do it, but that has really helped. We do 2 days back to back, or a Monday and then a Wednesday. That really helps. It helps with the communication at home, and it helps keep a flow within the classroom. We found last year we might have done it January 1st, and then they didn't come back till January 15th, and they came back in February. And that time between, the bonds weren't formed with the kids and the reset person, and we didn't have the continuity. But having them coming closer together has really helped. Let me see. So at the end of last year, I told George that we were going to focus on weather this year. And we got together at the beginning of the school year, and George came in with what he thought his ideas were for weather. And I had my ideas, and what was great was we had some of the same ideas. Some things he had included balloons going up with thermometers that ended up being taken away in the wind. But he had some great ideas that I would not have come up with, I'll be completely honest. So it worked out really well. He's working with my third graders this year. That worked wonderfully. And then science fair is next week. And I said, you know, science fair's coming. I'd really like to do something I've never done with my class before. I'd like to break them all into groups, and I'd really like each group to do a project. And he's like, okay. And he didn't realize how stressed I was over this. And so we came out with some ideas. He had some, I had some. Some of his ideas seemed a little too adventurous. Some of my ideas seemed a little too adventurous. But we came up with a total of 8. We ended up using 7 of them. And we had simultaneously in one class, we had 4 different science projects going on. In this packet that's in front of you, I've included a lot of the projects that we did. I've also included Barrett's scientific method. That scientific method is used everything from kindergarten to 5th grade within our school. Also within that packet is I pre-taught the scientific method and some other things to my students. So that lesson that I pre-taught before he came is in that packet as well. And the questions that are in there came from 4th and 5th grade SOL test questions. As I said, we email each other a lot. But when class is over, even if it's my planning block, we may talk for a few minutes afterwards, but he normally does go ahead and head on to his next adventure, whatever it is that day, because I'm trying to get ready for something else. We do a lot of our communication over email. I don't know, I think yesterday was the first time we've ever talked on the telephone. Normally it's over email, or we schedule a meeting. We might have a meeting on a teacher planning day or something like that. Next week's going to be his last week with us this year because he's moving on to other things. And John had sent out an email saying that Reset would fund up to $5 per child for the volunteer to give something at the end of their time with the students. And so George and I talked, and I live way out in the burbs. And so I went to a store called Five Below, which I love, and they had these items that were $5 each. And so next week to my class, I wanted all of these, but actually I wanted something else, but they were all sold out. So I had to buy a few of these because they didn't have enough. But these will be given out to my students next week. We have another volunteer who's here today, Steve. He bought these. He's in another class of third graders, and they were building things with Connects this year and doing bridge building and so on. So he bought these. I'll be honest, he spent more than $5 for his group, but it was my understanding he made up the difference personally. And George and I weren't in the position that we were willing to do that, but we think we got cool items as well. So, but these are just some of the things that we did. Five Below, awesome store if you have them anywhere near you. They normally have science kits, and it's F-I-V-E Below, B-E-L-O-W. Everything in the store is $5 or below, and especially around the holidays they have really cool kits. You can sometimes get kits that are Steve Spangler kits and so on. If you know anything about Steve Spangler, he's a really cool guy. He's kind of like Bill Nye. Something else, like I said, science fair at our school is next week, which is a big deal at our school, and some of the Reset volunteers are coming to our school for that. And if you have nothing to do next Thursday night, from 6 to 8, our address is in that packet as well. You are welcome to come over to Barrett Elementary and join us. Unfortunately, we were trying to get an astronaut this year. We did not get that, but we have had astronauts in the past. But we do have many really cool things that will be going on at that time. We will have huge displays of science boards and so on if you want to come and get some ideas of things that you can do with your students. And we're right here in Arlington. And that's from 6 to 8. And one more thing. I asked my students the other day what they think of Mr. Pick, and they said he's a great teacher and he makes science clear. And then they go, oh, you do too. and a little quieter, and you could tell they were getting a little nervous. So in closing, I want to say, tell me and I'll forget, show me and I'll remember, and I do and I understand. So if you always keep those things in mind. So thanks so much, because it really makes a difference for us and our kids.
Thank you, Susan. So we have some time for questions, comments, other ideas of what makes things resonate with the students.
Yeah, I have a question. Excuse me.
Oh, they didn't bring any water.
I like all the pendulum stuff, but I wonder how far you can go. I mean, at what point is there ever a point where you get too much information that they can't absorb?
I think there is. That's why I said the SOLs is a good reference, or Common Core, depending on which state you're in. I think this is my opinion, but I'll let you,
Yeah.
I think that you can go too high, and so that's one of the things that we've worked on is, he gives his ideas and then I'll say, oh, I don't know, I think that's too much. Sometimes things he comes up with are a little too high for me and he has to explain to me first. and then he starts talking to the kids and I go, and this is what he's talking about because he's explained it to me beforehand.
Yeah, well, I would like to say that what I was just trying to show or demonstrate, that this experiment can be used from the 2nd grade to the 5th grade easily by asking different questions and demonstrating it on a pendulum. I am not implying that we did all this on the 3rd grade.
No, we did not.
But that's a valid question, incidentally. We together work as a team, and I want to make sure always that when I explain, when I ask them questions, that it's on their level. I'm not trying to be smarter than they are. I'm trying to find out what they know and what they don't. So it's a back and forth between students. And I think that works very well, incidentally. There are students who have a tendency, for example, to put their arm up, even if they don't know the answer. But that's okay. And then we try to clarify. And then we try to bring in students who never put their arm up. So we.
And the 3rd grade lesson that we did with this was the length of the string. That's what we did with our group.
They limited it to like one major question, hypothesis or something.
If I may add, like she was saying, we teach to our SOLs and our curriculum and whatever the state tells us to teach. So as for
Can you give
overloading.
an example of that? I'm not, maybe it's just me, but I don't really know what the SOLs are, what they do.
I didn't bring any with me.
So an
It's in
SOL
the
is a
card.
standard of learning. So what the objective of what you have to teach that student in that grade.
I would say if you want to. And it's easy to go to va.sol.edu and you can look up all the science standards, the math standards, the English standards, whatever you want to know.
Yeah.
And
So
it's very easy to find out.
My SOLs have nothing to do with science besides the human body, because I'm health and phys ed. So something would be if students are proficient in manipulative motor skills, so skipping, running, jogging. And it just tells you what you have to teach them.
How would it apply to the tsunami?
How do I apply my
How would
standards
the
to?
existence of the SOL sort of determine how you approach the students?
Well, if the SOL has to do with, your students have to know things about the layers of the ocean or the tectonic plate shifts and anything like that, then it applies to that. But with the overload of information, there's always room in a lesson plan to add questions for students who get it and students who don't get it. So there's always room for changing it.
And usually what the Virginia SOLs, what they were intended to do back when they were created, was to divide up different topics by grade level. So, and it's on a cycling, spiraling kind of curriculum, so that in second grade they might talk about weather at one level, but in fifth grade the weather might also be part of the SOL standards, so that they're approaching it at a different level. So with the help of your teacher in your classroom, when your teacher says to you, we study weather, or we study energy, or we study whatever, they're getting that often from the SOL standards, or there's a whole nother series called the Common Core. The National Science Teachers Association has just come up with a new system of standards by which science teachers should follow. So there's a lot of different things out there, and it's important to ask, if you're interested, it's important to ask your partnership teacher, but that your partnership teacher will tell you, I need lessons on weather, or I need lessons on energy, because that's what their SOL or their standards tell them they need to teach.
For a lot of our volunteers, we do try to line up the scientific discipline that the volunteer wants to introduce with the appropriate grade level for those standards. We also have the standards on our website. both DC and Maryland are going to what are called the next gen science
Which
standards.
is the National Science Teachers Association.
Right, right.
Creation.
On different schedules. I think DC's in transition now, hopefully to be fully implemented by 2016 to 17. Maryland is looking at 2017 to 18, and Virginia hasn't shown any interest.
No, we're on our own.
Virginia being Virginia.
Like, I was going to pick up on what you said about it going too high a level. What you'll find, I think, is within a given classroom, you'll see kids at a pretty wide range of background knowledge, familiarity. So, and then, for example, I teach with Susan's colleague, and one of her, because they divide their classes based on their Spanish language skill, my Tuesday group, which is weak in Spanish, but they tend to be kids who are otherwise very strong academically, relatively speaking. And then the reverse happens on my Thursday. So half the kids in that class have very limited English skills so far. They're still developing their fluency there. So we have bilingual, translating. Their peers are helping them out, and Allison, my teacher, make sure we reinforce the vocabulary so they understand how to spell it, what it means. All right. And because I just finished retiring from teaching high school math, so I'm able to relate stuff. We're doing like ballistics and parabola arcs now. I taught them Angry Birds stuff, and they really got it. They're working on that right now for the science fair. That if you probe their curiosity, before you say, well, here are what you need to learn, but rather, what could we possibly want to know about whatever it is you're talking about, whether it's a tsunami like you posed, all the possible things that might affect the houses on the shore. And we go into, well, what are the things we might want to know and want to be able to measure? And then in my introductory thing, when we started the project, I actually showed them stuff that was way, way beyond elementary school. All right, as a ending of this thing, I said, this is going to look very confusing. You're not going to know what I'm about to present. So you present to them. They're not. The next page they see, they're going to be confused about, but you prep them for that. And they see, even your mom and dad are not going to know a lot of the stuff I'm about to show you. And I then presented all these math equations for related to ballistics and parabolas. And the funniest question I got from one of the kids was, how come there's, they thought it was math. They said, how come there's so many letters up there? All right, instead of numbers. And tried to explain the concept of a variable, and that's because my other school I'm working at, they're just beginning to get into the pre-algebra, and that's in third grade now. But getting them curious and engaged and thinking, all right, is an important thing. They may not pick it up, but many of them won't pick up everything you have in mind. I think that's the key thing, and get the basic notions of the scientific method. Have them have a chance to experience that idea, and we have them collecting data and graphing data and things like that.
I would say piquing their interest is definitely the biggest thing. You want to get them to want to be excited about learning. If you give a student something they know well and that's boring to them, they're not going to want to keep doing it. So when you know nothing about a tsunami, you want to know everything about a tsunami.
And what's better than houses being
I know.
trashed by
Yeah, destroying things.
Yeah, I was thinking that you were talking about having that last slide or that last thing showing something, well, here's how we really look at it. Here's what engineers do or something, with that next level. That would be something, I'm sure there's going to be some that may feel intimidated by it, but I think I can see where it would inspire others to say, hey, I want to pay attention. I want to know what that is. I want to be able to do
what
that.
I'll do is I'll say, when you get to middle school, we're going to look like this, and then when you get to high school, it's going to look like this.
Cool.
And then when you get to college, because actually this one I got up way beyond, and we said these are these really weird-looking things that people are going to use to analyze this stuff. And it's still your Angry Birds going through the air, but these are all the ways we measure what's happening. So.
Cool.
I find something that the kids seem to like is the notion of being able to connect, somehow the science with things that they can appreciate. To make predictions, for example, like distance is 1 f/8 squared. It's an easy equation; you can handle that. And they realize, gee, if I drop a penny, it takes 2 seconds to get down. You can work it out. You can figure out how far it dropped, how long it took. And be able to find connect, so they can measure with their watch to like a real life, thing. And they go, so that's why there's math.
Well, we did look at
like
the first thing we built bridges, and then we destroyed the bridges. But we had pictures taken. Then we destroyed the bridges, and they had to measure. They had to predict. Each team built their own design after they saw some basic models, and then they got a chance to destroy the bridges over an imaginary river canyon. Was an experiment. But in the idea, they got really nervous, when they could start to see the bridge starting to wobble and cave, and then they eventually gave way, and they kind of could see them all kind of. And then the team that won had the strongest bridge, was one prize.
So I think we're coming to focus on what gets kids excited about science, and it's destruction.
I agree with that 100%.
And should be.
Yep.
That's better.
I had we were talking about pressure, and I had inflated a bag of Doritos real tight to show what happens when they go up in an airplane, and how the pressure changes. And they were yelling at me to pop it. Smash the bag. And then at the end of the class, the guy was sitting in front of me, was staring at me like he was so interested. He said, "Can I have those Doritos?"
Another thing that makes kids
Food is good, instruction is good.
Well, let's thank our panel for that. Now, Sherry is going to talk about practical tips for the classroom.
And I'm not good at sitting. So I've taught everything from K through high school science in my history. And I've been really excited by Reset's opportunity that they've given me to go out and work with all of you if you desire to come and look. In fact, I've seen this tsunami lesson. I've worked with George and at Barrett, and they've all been great experiences. So before I start with my creative idea, when I said to my 25-year-old daughter this afternoon, I'm going to do Jay Leno's list of 10. And she goes, huh? Does everybody here know who Jay Leno was in his list of 10? Okay, just to make sure. So I was like, you don't know who Jay, whatever. It was just a little moment for me. But anyway, so I was asked to do, to come up with some tips that I've given many of you in this room, and some that I see repeatedly, and many of you do these things already, but maybe I can throw in a little caveat or something to help you. So number 10 is use students' name when possible. So I know that you come into a class and at the beginning you don't know all the kids, but it's not difficult for a classroom teacher to have the kids slap on their name, write their name, and put it on a sticky note ahead of time. And it makes a real difference when I say